In Activity 11, Measuring Freezing Points, students investigate the temperatures at which various materials change state from liquid to solid and conclude that not all substances freeze at the same temperature. You will need the following materials from the kit: Activity Sheet 11, Celsius thermometers, plain tumblers, butyl stearate pails, salt, and masking tape. You will also need to provide red crayons, crushed ice, long-handled ladles, paper towels, large spoon, and tap water. To prepare for Session 1, make a copy of Activity Sheet 11 for each student. Use masking tape to label 2 pails A and 2 pails B. Fill the 4 pails 3/4 full with tap water and pour a tumbler full of salt, about 9 ounces, into each B pail and stir thoroughly with the spoon. Make sure that your students do not see that you added salt to the B pails and return the salt to the kit immediately. Use crushed ice and tap water to make 2 pails of ice water. Set up a distribution station with the 4 pails of liquid labeled A and B, the long-handled ladles, the 2 pails of ice water, and paper towels. Place the bags of butyl stearate in a pail of warm water to melt them. Each team of 4 will need 2 strips of masking tape, 3 thermometers, 3 tumblers, and a bag of butyl stearate. To begin Session 1, review the terms melt, melting point, and freeze with the class. Ask students, what do you think freezing point means? Guide students to understand that freezing point is the temperature at which liquid changes to a solid. Tell them that in this activity, they are going to measure and record the freezing point of 3 different substances, 2 with which they are familiar, and 1 of which is unknown. Assign a number to each team of 4 and distribute the materials. Instruct students to use the tape to label both tumblers with their team number and have them label one tumbler A and the other tumbler B. Show students the pails of liquid and tell them that A pails contain water and the B pails contain an unknown substance. Have the students fill their A tumbler from an A pail and fill their B tumbler from a B pail. Note that the tumblers should be about 1/4 full. Students should then place a thermometer into each tumbler, bulb down, and place the tumblers in the freezer. Next, give each team a bag containing liquid butyl stearate, a thermometer, a tumbler, and a paper towel. Hand out a copy of Activity Sheet 11 with a red crayon to each student and ask, how do you think you could find the freezing point of butyl stearate? Accept all reasonable suggestions, and then invite teams to use the ladles to fill their tumblers about half full with ice water. Have students place their thermometers inside the bags of butyl stearate, deep enough in the bag so that the bulb of the thermometer is covered by the liquid. Then, have them reseal the bags, enclosing the thermometers, and gently place the bags in the tumblers. Next, students observe the butyl stearate until it becomes a solid, which should take about 10 minutes. Instruct students to record the butyl stearate's appearance, temperature, and freezing point on the activity sheet's chart. After they've recorded their observations, have students remove the bags from the tumblers and set them on a paper towel. Ask them to open the bags of butyl stearate, remove the thermometers, and reseal the bags again. To conclude Session 1, make sure to collect the activity sheets for use in Session 2. To prepare for Session 2, remove the A tumblers of frozen water from the freezer at least 5 minutes before Session 2 in order to allow the temperature on the thermometers to rise and stabilize at 0 degrees Celsius. Make sure to remove the saltwater B tumblers from the freezer immediately before the session begins. Each team will need their A and B tumblers with thermometers from Session 1 and a red crayon. To begin Session 2, give teams their tumblers of water with thermometers in them from the freezer and their activity sheets. Instruct them to observe the substance in each tumbler and record its temperature and appearance in the chart on the activity sheet. Ask students, what happened to the water? Students should observe that the water froze. Then ask, what is the temperature of the water? Students should respond that the temperature is 0 degrees Celsius. Finally, ask students, what is the freezing point of water? They should say that the freezing point of water is 0 degrees Celsius. Next, ask students to observe substance B. Substance B will have probably remained a liquid, although it could be frozen slightly depending upon the temperature of the freezer. Ask students, what is the temperature of substance B? They should observe that the temperature is about -10 degrees Celsius. Then ask, can you tell what the freezing point of substance B is? While students cannot yet discern the freezing point of the substance, They may be able to figure out that the freezing point must be at or below -10 degrees Celsius. Ask students, what is the freezing point of butyl stearate? They should respond that the freezing point of butyl stearate is 20 degrees Celsius. Have students record the freezing points on their activity sheets. Next, ask students, did all 3 substances freeze at the same temperature? They should respond that none of the 3 substances froze at the same temperature and therefore had different freezing points. Students should recognize that butyl stearate had the highest freezing point, while substance B had the lowest. Explain that substance B is a mixture of salt and water, and that salt water is a different material from pure water, and thus has a different and lower freezing point. This is one reason that salty ocean water is slower to freeze than fresh lake water. Reiterate that the freezing point of every type of material is different from every other. Therefore, the freezing point of a substance is a characteristic property of that substance. Just as with melting and boiling points, your students can use freezing points to distinguish between unknown substances. Next, ask the class to identify the freezing point of pure water and the melting point of ice. Students should report that both are 0 degrees Celsius. Then, ask the class to identify the freezing and melting point of butyl stearate. Students should identify the melting and freezing points as 20 degrees Celsius. Ask students, what can you conclude about freezing points and melting points? They should deduce that all freezing points and melting points of the same substance are the same. Finally, explain to students that at the freezing point and the melting point of a particular substance, its temperature is the same. What differs is whether heat is being removed, freezing, or added, melting. To conclude the activity, remove the thermometers and pour out all ice and water. Rinse and dry the cups and containers, and return all materials to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.